All right, the next concept we're going to look at in stoichiometry here is something called excess reactance. Before we do that, we're going to look at sort of a conceptual concept map, I guess you could say here, regarding reactants, limiting reactants. I just want you to sort of look at this, maybe take some notes of it, just kind of see what's going on with this. The first thing you'll notice here is it says we have 6 moles of each of these reactants right here. You'll notice also there's a balanced equation right here. So that balanced equation actually would be, just as a reminder, this would be a 1. We have a 3 right here and a 2. And remember, the balanced equation says, basically focuses on mole ratio. If you look at the 6 moles of each thing, and down here we look at the key is right here, we can say, okay, well, we have 6 of each of the reactants. So if you look right here, 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6 of nitrogen and hydrogen. So there's 12 total reactants here, 6 of each, and that's where that 6 comes from. So what we're going to do is we're going to say, well, let's take a look at what's actually going on here. What it's saying is for every 1 nitrogen molecule that reacts with 3 hydrogen molecules, I can make 2 ammonia. So let's just go ahead and make 2 ammonia. So what we got here, I just took out 3, 1, 2, 3 of the hydrogen, and I took out the 1 nitrogen right there. So 1 to 3, and how many ammonias will I make? I will make 2. So there we go. There's my 1 and my 2. Well, we still have some reactant left, so let's do it one more time. So we're going to cross off again 1, 2, 3, and 1, a 1 to 3 ratio, which then will make 2 ammonia. Again, that makes sense. So we kind of notice that we're done with this reaction because all we have left is 1, 2, 3, 4 nitrogen molecules, but we have no more hydrogens left, so we can't do this anymore. So we actually ran out of one of the reactants. So let's kind of see what happened here. So again, before all this started, to kind of recap, we had 6 moles. We had 6 right here, 1, 2, 3, 4, 5, 6 of nitrogen, but we also had 6 of hydrogen too. We had 0 ammonia so far over here. Now we got plenty over here on the after side. Let's focus on the change. What happened? Again, I subtracted 2 of the nitrogen, and if I erase all of my, let's just go ahead and erase all this stuff here, I'll see, give me a second here, that I have used 2 of these right here. So there's 1 and 2 that I've used of the nitrogen. I've also used 6 hydrogens. Now 1, 2, 3, 4, 5, 6. In fact, I ran out of hydrogen. So then I made 4, and you can count them over here in the yellow, 1, 2, 3, 4. So after, what did I have? Again, I have 4 of the nitrogen left. There's 1, 2, 3, and 4 nitrogens left. I have 0 hydrogens left, and I've produced 4 over here. So what we've talked about here is our hydrogen right here has actually ran out. It's our limiting reactant because we ran out of it. We don't have any more left. And then our excess reactant would be nitrogen. And that's important. That's the new term we're focusing on here. The excess reactant is the other one. It's not the limiting reactant, it's the other one. So what does that mean? Well, it means that we could actually set this up and we could calculate how much of that other one is left. So if we kind of look at this and we say, okay, well, here's the reaction again, a different reaction. And we say we have 40 grams of nitrogen and we have 10 grams. So first of all, let's do the 40 grams. So we just run it through here. We're going to see how much nitrogen will we actually make. So I do my grams to moles, to moles, to moles, right? And then I do one more, moles to grams. And that gives me how much ammonia I can make. Now I'm going to do it again with the 10 grams of hydrogen. So again, grams to moles to moles to grams, and that gives me a larger number. So this right here is my number that is smaller, so that makes this number right here the important one to focus on. So the question then is, how much hydrogen did I use up of the 10? Because we started with 10, that's important. But I know if I can make 48.6, remember this is my theoretical yield right here, that means 40.6. All I would need to do is, instead of going from nitrogen, grams of nitrogen to grams of ammonia, I could actually go grams to moles to moles to grams of hydrogen. If I do that, I can, based off of mole ratios, figure out how much hydrogen was actually used. So again, I'm going to go, and again, just kind of focusing on what's the smaller number, I'm going to use the limiting reactant to find how much excess is made. So I'm going to go with my 40 right here. Since this guy is a smaller number, I'm going to take that 40, I'm going to put it down here, and now I'm going to convert grams of one of the reactants, which is the limiting reactant, and I'm going to convert it to grams of the other reactant, which is the excess. So again, I'm going to go 40 grams to moles of nitrogen, and then I'm going to go moles of nitrogen to moles of hydrogen, just like I said I would up here. After that, I'm going to go moles of hydrogen to grams of hydrogen. That will give me 8.63 grams of hydrogen used. Now, again, I started with 10 right here, so that's where that 10 came from. If I started with 10, then I would just take this amount right here and I would subtract it. 10 minus 8.63, and I'm left with 1.37 grams. That's called my excess. How much is left over? Because remember, I used all 40 grams of nitrogen. I didn't quite use all 10 grams of hydrogen, right? Let's look at the question that's on the packet that I gave you. We printed it out already, so let's just do the first one together. The first thing we would need to do is look at this equation. We need to balance it. So I balanced it there. I did that for us quickly. The second thing we would need to do is look at these numbers right here. This number, which is of one reactant, and this number, which is of the other reactant. And it says that I'm focusing on one single product, which is this one right here. Okay, not any other one, just that one right there. Okay. All right, so I got those things working for me. What do I do now? Well, I'm going to go from grams of one thing, one reactant, and I'm going to go to that. That gives me 342 grams to moles to grams. I'll do the same thing with the 217. I'm going to go boom to boom right there. And I can see that 342 is the smaller number. Again, so I look at this and I say, okay, well, this is my limiting reactant. I use all 409 grams of zinc sulfate. So then I go over here and I say, well, I started with 409. All I need to do is convert. Again, let me get this stuff out of the way. I am now going to go grams that I started with of one reactant, the moles to moles, the grams. And I want to figure out how many grams of oxygen did I use. I know what I started with, which was 217. How much did I use and how much is left over? So again, I'm starting with my grams right here. I'm going to moles. I go to moles of oxygen and then grams. So my grams to moles to moles to grams. And you can see it's a number that's fairly close. I have 201. I started with 217. So that makes sense. So how much did I start with? 217. So I'm going to go 217 minus 201, and that gives me 16 grams of oxygen. So that would be my answer as far as excess reagent or reactant. Remember, those words are sort of interchangeable. Last but not least, if we look at this in terms of percent yield, remember, and you probably have a pretty good handle on this from the lab, but remember, since this is the limited reactant, zinc sulfide, this is our theoretical. And our theoretical is always going to go on the bottom, 342. And let's say we actually did this lab. If we did this lab, we'd get an experimental value. That experimental value would go right here in the top. Experimental value. Let's say it's like 333. That's a fun number. And we take 333 and we divide it by 342. And then we multiply 100 to get our percent yield, which is a pretty easy concept. And I think a lot of you really understood that through the lab that we did. Just want to make sure you understand. Theoretical comes from your limited reactant, your smaller number. The smaller number is actually your theoretical. Theoretical goes on bottom. Experimental is what you got after you did a real experiment. And you divide the experimental divided by the theoretical multiplied by 100. So those are two new concepts that build on the ones we've already covered. Hopefully that makes sense to you. And go ahead and work on the practice problems.